Simplifying, multiplying, and dividing rational expression. Remember, rational expression is a fraction where the numerator and or the denominator are polynomials. So first we need to look at the excluded values. Excluded values are the numbers that make an equation undefined. Basically, it's going to make the denominator 0. So what we do is we take the denominator and we set them equal to 0. Here the denominator is x plus 3, so we write x plus 3 is equal to 0. We can subtract 3 from both sides, and that gives us x is equal to negative 3. So our excluded value, if we were to solve this, we would say that the excluded value, x, cannot equal negative 3. And we'll get into solving later on. Now, if you remember when we found the domain and the range, the domain for rational expressions is always all real numbers except for your wholes or your vertical asymptotes. Here, we're going to have a vertical asymptote at negative 3. So we would say the domain is going to be all real numbers such that x does not equal negative 3. Now, when we're just simplifying and not solving an equation, they're called restrictions on the variable, basically what numbers the variable cannot be. When we're solving, it's called an excluded value. So since the end goal is to solve this, I'll usually call them excluded values. When doing this, we need to set the denominator equal to 0 and solve. So we're going to be solving by factoring. Factor this out, set it equal to 0, and solve. So the two excluded values or restrictions are going to be x cannot equal negative 3 or negative 2. Now, a common mistake that students make is they simplify first and then look for those restrictions. Always find the excluded value or the restrictions first before simplifying. This one's pretty straightforward. We set the bottom equal to 0. The bottom here is simply 12x. Set it equal to 0. Divide by 12 to get x is equal to 0. So our excluded value, our restrictions, is x cannot equal 0. Now we can go through and simplify this. I have a 3 and a 12. The 3 cancels out, becoming a 1. The 12 cancels out, becoming 4. Next, I have an x squared on top and an x on the bottom. Ask yourself, where do I have more x's? I have more on top because it's a squared. That means the bottom one is going to cancel out completely. And how many more do I have on top? I have one more on top, and that means you're going to have x to the power of 1. That leaves you with an x on top, and on the bottom, the only thing that's left over is the 4. So the simplified version is x over 4. If I had waited to find the excluded value until the end, I wouldn't have had any because now there's no variables. That's why it's important that you find the excluded value first and then simplify. Here's another one. We're going to simplify and find those excluded values. We need to set the bottom equal to 0 and solve. And when I do that, I need to factor. So we're going to factor the bottom, and while I'm at it, I'll go ahead and factor the top. To start with, I have a 2 as a GCF. Then I can factor it again. Always keep the GCF on the outside. We ask ourselves what two numbers multiply to negative 21 but add up to 4, positive 7, and negative 3. So I use this, and then I use that. While I'm here, I'm going to go ahead and factor the top. If I look at the top, it's written backwards. The x is negative. I need the x in front. I need the x positive. When I take out the 6 as a GCF, then I'm going to take out a negative 6 also in order to switch the signs. Put the GCF on the outside, and negative 6 divided by negative 6 gives me a positive 1x minus 18 divided by negative 6 is that negative 3. On top, I have negative 6, parentheses, x minus 3. Before I go any farther, I find those excluded values. I take the bottom, and I'm going to set it equal to 0. My two restrictions on the variable are x cannot equal negative 7 and x cannot equal positive 3. At this point, I can continue the problem. I'm going to go ahead and rewrite it just to make it look neater. Now I can start reducing. I have a 6 and a 2, and that can reduce to 3 over 1. I have an x minus 3 on top, and I have an x minus 3 on the bottom. I can cancel both of those out. That leaves me with an answer of negative 3 on top with an x plus 7 on the bottom. So that is the simplified version with the two restrictions of x cannot equal -7 or +3. Now also note, the negative sign is on top here. If you put the negative sign on top, you're fine. If you put the negative sign in the middle, you're fine. If you put the negative sign on the bottom, then you're probably going to be marked wrong. Remember that negative sign needs to either be in front of the fraction or it needs to be on the top of the fraction. A quick review, finding the domain. If we're finding the domain of a rational function, it's the same thing as finding the restrictions on the variable or the excluded values. The domain for these rational functions is what sets the denominator equal to 0. That's either going to give us a whole or a vertical asymptote, and we learned about that before. So since it's applicable to what we're doing now, we'll just go ahead and do a quick review. Factor out the bottom, and then factor it again. Now set each factor equal to 0. Our domain on this is going to be all real numbers such that x cannot equal 0, 2, or 3. And so I like this because a lot of people make the mistakes on the 0. They forget to put that extra x set equal to 0, and that's why I wanted to review this with you. So this would be the domain of the rational function. A quick review on multiplying fractions. When you multiply fractions, the numerators multiply and the denominators multiply. We literally multiply straight across. 2 times 4 is 8, 3 times 5 is 15. Now if possible, you're going to want to cross cancel first or reduce top to bottom. It doesn't have to be across, it can be anywhere on top and bottom. So here I have a 2, can cancel out with the 4, and that becomes 1 over 2. Now I can multiply straight across, and that gives me 1 times 5 is 5, and 3 times 2 is 6. Always look to see if you can still reduce. If you can reduce, that just means you didn't cancel out enough, and that's perfectly fine. Just reduce it at the end if you haven't canceled it. Now people look at this question and say, that's not multiplying two fractions, and I say, you're wrong. That is multiplying two fractions. You have one fraction here, and remember, anytime you have a whole number, it's always going to be over an invisible 1. So the first thing we need to do is set the bottom equal to 0 and solve it, but in doing that I'm going to factor it. So I'm just going to go ahead and rewrite this a little bit neater in a factored form. I have a GCF of 4, so I can pull out the GCF of 4, and that leaves me with the y plus 2. The other one is still over 1, and hopefully you can see that's a difference of two squares, which gives you y plus 2 and y minus 2. Now I only have one denominator here, the y plus 2. I don't need to worry about the 4. So I'm going to take that denominator and I'm going to set it equal to 0. And we're left with y cannot equal -2. That's my restrictions on the variable or my excluded value. Now I can continue with the problem, and before I multiply, I look for things to cancel. I have a 12 on top and I have a 4 on the bottom. That can reduce to 3 over 1. I have a y plus 2 on top and I have a y plus 2 on the bottom, which can cancel out. Y minus 2 on top and nothing left to cancel. Now most of you will probably do this in your head, but I'm going to go ahead and rewrite it for completion. We have 3 times y minus 2, so we write 3 times y minus 2. And then we have 1 times 1, which is simply 1. Now the big issue here is don't forget to distribute. This y distributes to both of those, and that leaves us with an answer of 3y minus 6. Now 3y minus 6 is the best answer. However, on Math Excel and some of the other books, I have seen them want you to leave it in the factored form. So make sure you are reading the directions before answering the problem to see if they want you to leave it in the factored form or if they want you to distribute the 3 through. Next is dividing fractions. Whenever we divide fractions, we invert and multiply. What does that mean? It means to take the reciprocal. That's what invert means, is to take that reciprocal. So you take the reciprocal of the second fraction. The 2 over x stays the same. Now for that second fraction, we take the reciprocal, x squared over x plus 4. So we inverted it, and that division sign is now a multiplication sign. And then we treat it just like multiplication. We look for things to cancel. I have a 2 on top, but I don't have any factors of 2 on the bottom, so there's nothing I can do there. I have an x squared on top, and I have a plain x on the bottom. Ask yourself, do I have more on top or bottom? I have more on top, so that cancels out. How many more do I have on top? I just have one more on top. Now we multiply those through. 2 times x to the power of 1 is simply 2x over 1 times x plus 4 is simply x plus 4, and we're finished. Key mistakes here, people try to reduce the 2 and the 4. They can't. The 2x on top, those are two factors. The x plus 4 on the bottom, that is one factor. He's a binomial. You cannot break him apart. If you have another x plus 4, you can cancel those, but you cannot split the top to make it cancel the bottom. It does not work that way. Now, sometimes fractions are written side by side, and sometimes they're written on top of each other. Here again, people say, but that's not a fraction on the bottom. That's a whole number. Remember, all whole numbers have the invisible 1 on the bottom. Now, we're going to do the same thing. We're going to invert and multiply. If it's side by side, you take the second fraction. If it's on top and bottom, you take the bottom fraction and flip that upside down. The first fraction didn't change. The second fraction becomes times, and now I flip it upside down, 1 over 4x cubed y cubed. At this point, I can start canceling things out. I have a 6 on top. I have a 4 on the bottom. The 6 and the 4 can reduce to 3 over 2. I have an x squared on top. I have an x and then an x cubed on the bottom. You can choose however you want to cancel these so that I don't have to multiply later. I'm going to actually cancel it twice. I have an x squared on top and I have an x on the bottom. The x cancels out completely, and x squared reduces to just x to the power of 1. Again, I have an x to the power of 1 on top and an x cubed on the bottom. Now the x to the power of 1 is going to cancel out completely, and x cubed is going to reduce to x squared. I have a y5 on top and a y3 on the bottom. Since I have more y's on top, the y3 cancels out completely. The y5 becomes 2 because 5 minus 3 is 2. Now I can simply multiply straight through. I have a 3 on top, and I have a y squared, and I have a 1. So 3 times 1 is simply 3, and that gives me 3y squared on top. On the bottom, I have a 5, and a 2 gives me 10, and I have an x squared left over in the bottom. Always double check to see if you can cancel or reduce any more. We can't, so we can move on. Now, I chose this problem specifically because of those negative exponents. So we have negative exponents and we have divisions. There's a lot of flipping going on here. We need to be wise in how we do it. Always start, whenever you have negative exponents, by taking care of those negative exponents first. Remember, they are individuals. We treat them individually. You cannot, just like a crying, whiny baby, you can't get anything done as long as the baby is going crazy. So what do? You take care of the baby, you take care of his needs. Here, the y to the negative 3 needs to come down, and the x to the negative 8 needs to move up. Notice, I'm not going to change the coefficients, the 8 and the 3, because their exponent is an invisible 1 and is perfectly fine. We treat each of these as individuals. I'm going to rewrite the first one, 2x to the 5th over 3y squared. It's still division. I haven't changed that. I haven't changed the coefficients, 8 and 3, but I am going to change the variables. Y to the negative 3 is not happy on top, so I'm going to move him down to the bottom, y cubed. X to the negative 8 is not happy on the bottom, so we move him to the top, x8. I treat them as individuals. Now I can invert and multiply. So now we're going to flip the entire second fraction and change it to a multiplication. Again, the first fraction doesn't change. The second one flips. Now I can start reducing. I have a 2 and an 8. The 2 cancels out and becomes a 1. The 8 becomes a 4. I have a 3 and a 3, both becoming 1. I have an x to the 5 on top and an x cubed on the bottom. That means the x5 cancels out completely, and 8 take away 5 is 3, leaving me with an x3 on the bottom. I have a y cubed on top and a y squared on the bottom. I have more y's on top. That means the bottom one cancels out completely, and 3 take away 2 gives me y to the power of 1. Now I can go through and multiply whatever's left over. On the left-hand side, I have the 2 canceled out and the x5 canceled out. The 3 canceled out on the right-hand side, leaving me with a simple y on top, over. And then on the bottom, again, the 3y squared canceled out completely. I have a 4x cubed left over on the bottom. And then it did ask for restrictions, so obviously both x and y cannot equal 0 because there's no adding or subtracting there. So those are the restrictions. All right, I want to do one more multiplication problem with you, simply because there's a lot of factoring and a lot of restrictions that they're going to ask about. So the first step is to find the restrictions or the excluded values. In order to do that, I need to factor the bottom. So I'm just going to go through and factor everything to begin with. Remember, factoring should be second nature to you. You should be able to factor very quickly and easily. Now that I have all of the factors, I need to find the restrictions or the excluded values. So I take the bottoms, all of them, and set them equal to 0, and solve. So all of these will be my restrictions. Now sometimes they want you to simply list them, and a lot of times they say from smallest to largest. So again, make sure you're reading the directions. Now we can move on to the multiplying. Before we multiply, always try to simplify by canceling things out. Here I have an x minus 6 on top, and he's going to cancel out with the x minus 6 on the bottom. I have an x minus 3 on top, which is going to cancel. I have an x plus 1 on top, which again can cancel. And then I have another x plus 3 on top, which again can cancel. Now, there's no multiplying. Everything canceled out. The sad part is lots of students miss this problem. They give me an answer of 0. But no, remember, when something cancels out top to bottom, what's left over? A 1. So your answer is simply 1 with all of those excluded values or restrictions. Remember, they're excluded values when we're solving. Now we're simplifying, so it's just restrictions.